In this video, I will explain find the complex exponential Fourier series of the function of the periodic function x of t shown in figure below. Determine Fourier series coefficients from complex exponential Fourier series quotient from complex exponential Fourier series quotient. Plot the magnitude spectrum. This is the statement. Function of this function is x of the axis. Here 1, 2, 3, 4. This one is 4. The 3 to 4, the function value is -1. Here 1. 4 to 5, the function value is 1. 4 to 4. Here -1, 0, -1. That frame that -1 case the function value is -1. This one is -1. -1 here also -1. This one is 1. -1 here -2. -3. -4. -5. See the function. First of all, I have to calculate the time period of that function and then calculate a complex exponential Fourier series quotient. Here time period is here. This one is a starting point. The waveform is like that. Up to 3. After that, the waveform is repeated. Therefore, the starting point here is T0 plus T. This is the way we have to find out time period of the waveform. Or else, this one is T0 plus T. This point. At the 4. This is the time period of the waveform T0. Or else in the another way is find out the time period of the waveform T0 is like Consider first one. T naught is -1. Small t naught plus capital T naught is 3. Therefore, substitute T naught here. -1 plus T naught is equal to 3. Time period of the waveform T naught is equal to 3 plus 1 is equal to 4. In another way is T naught is 0. T naught plus T naught is equal to 4. Substitute 0 here. T naught is equal to 4. In both ways, the time period of the waveform is 4. Next one, find the complex exponential Fourier series. Consider first one, here -1 to 0, the value is 1, -1, not 1, -1. That means 0 to 1, the value is 1. Consider this point to this point, -1 to 0, the value of x of t is -1, 0 to 1, the value of x of t is 1, 1 to 3, the remaining 3, 1 to 3, that value is 0. That value is 0. Consider from this point to this point, from this point to this point, -1 to 0, the value is -1, 0 to 1, the value is 1, the remaining interval 1 to 3, the value is 0. X of t, complex exponential Fourier series representation. X of t is equal to sigma n is equal to -infinity to +infinity Cn e power j n omega naught t. Now we have to calculate Cn value. Cn is equal to, we know that 1 by t naught integral small t naught to small t naught plus capital T naught x of t e power -j n omega naught t dt. We know the time period of the waveform is 4. Substitute 4. T naught is equal to 4. 1 by 4. Small t naught means -1 to 3. -1 to 3 x of t e power -j n omega naught t dt. That is equal to 1 by 4. This interval -1 to 3 interval is divided into 3 interval. This one is -1 to 0, 0 to 1. But the value is 1, the value is -1. The remaining 2, 3, the value is 0. This is the x of t. Okay. -1 to 0, -1 to 0 into x of t e power -j n omega naught t dt plus 0 to 1. Here 0 to 1. X of t e power -j n omega naught t dt. Here 1 by 4. -1 to 0. The value of x of t is -1. The value of x of t is -1. E power -j n omega naught t dt plus 0 to 1. 0 to 1 interval. The value of x of t is 1. E power -j n omega naught t dt. For 1 to 3, I am not written here because the value of x of t is 0. Here 1 by 4. E power -j, this is minus sign. E power -j n omega naught t by minus j n omega naught in the interval 0 to -1 plus e power minus j n omega naught t minus j n omega naught t omega naught not t the interval 0 to 1. Substitute these values, limit values in the above equation. That is 1 by 4 minus e power 0 is 1 by minus j n omega naught. Substitute -1 here, minus e power, here t is -1, minus into minus plus j n omega naught by minus j n omega naught plus here 1 is substituted here minus j n omega naught minus j n omega naught minus 0 is substituted, e power 0 is 1 by minus j n omega naught. That is equal to 1 by 4 minus into minus plus 1 by j n omega naught minus into minus plus plus into minus minus e power j n omega naught by j n omega naught plus into minus minus plus into minus minus e power minus j n omega naught by j n omega naught plus into minus into minus plus 1 by j n omega naught. That is equal to 1 by 4 1 by j n omega naught plus 1 by j n omega naught is 2 by j n omega naught minus here e power j n omega naught plus e power minus j n omega naught by j n omega naught. That is equal to here 1 by 4 into 2 j n omega naught is 2 pi by t naught. T naught means t naught here t naught minus here 1 by 4 e power j n omega naught plus e power minus j n omega naught by j n omega naught is 2 pi by t. To here t naught is 4 1 by 2 into t naught by t naught here is 4 here t naught is 4 by j n 2 pi 2 4 here j 1 pi is there here 1 by 2 1 by 2 2 1 by 4 is written as 1 by 2 into 1 by 2 here 1 by 2 into e power j n omega naught plus e power minus a n omega naught by here one more 2 is there. Here T naught is 4, T naught is 4 by J n 2 J n 2 2 times 4. Here J n 2 pi. This one is Cn is equal to 1 by j n pi minus 1 by j n pi cos n e power jx plus e power minus jx by 2 is cos x. That is equal to 1 by j n pi is a common term. Cn 1 minus cos n omega naught is 2 pi by t naught. Omega naught is 2 pi by t naught. That is equal to 1 by j n pi 1 minus cos n 2 pi by t naught is 4. 4 means 2 times. That is equal to Cn is equal to 1 by j n pi 1 minus cos n pi by this is the cos n pi by 2. Cn is equal to numerator and denominator is multiplied by j into j here n pi 1 minus cos n pi by 2. Here j into j square minus 1, that is minus j pi n pi 1 minus cos n pi by 2. Now calculate mod Cn magnitude of spectrum. That is a square root of real quotient is 0 whole square plus imaginary term is minus 1 by n pi. That is 1 minus cos n pi by 2 square. This one is cancelled. Therefore, mod Cn is equal to, due to that squaring, the minus sign is changed to plus sign. Minus sign is that is equal to 1 by n pi 1 by n pi 1 minus cos n pi by 2. 1 by 1 minus cos n pi by 2 is we know that cos n pi by 2 is 1 minus 1 whole power cos n pi by 2. Cos n pi by 2 is equal to trigonometric identity minus 1 whole power n by 2 for n is equal to even 0 n is 0 n is 0. This is the magnitude. Suppose n is equal to this one is function for n not equal to 0. For n not equal to, suppose n is equal to 0, 1 by 0 means infinity, indeterminate term. That is the reason we have to calculate. We know that Cn is equal to 1 by T naught plus capital T naught sub T e power minus j n omega naught T dt. Put n equal to 0 in the above expression. C naught 1 by T naught small t naught plus capital T naught x of t. Here n is equal to 0 means c power 0, that is 1 x of t dt. Here t naught is 4. Initially the t naught value is determined 1 by 4, that is minus 1 to 0. X of t value is minus 1 dt, and 1 to 0 x of t is value is 1 dt. That is equal to 1 by 4. Here minus sign is bring out t minus 1 to 0, t 0 to 1. Substitute 1 by 4 minus 0. Here t is equal to minus 1, minus or minus plus 1. Here 0. This one is 0 to 1. 0 to 1. This one is 1. This one is 0. 1 minus 0. Minus 1 to 0. This is the function. Minus 1 to 0. 0 to 1. This one is 1 minus 1. Okay. 1, 0. That is equal to 1 by 4 minus 1 plus 1. That is, these two are cancelled. Therefore, C naught value is 0. C naught value is 0. Cn, we know that mod Cn magnitude function Cn is equal to we know that 1 by n pi. Cn is equal to 1 by n pi, 1 minus cos n pi by 2. 1 by n pi, 1 minus cos n pi by 2 for n not equal to 0. For even function, for even values of n, suppose n even, mod Cn is equal to 1 by n pi, 1 minus 1 whole power n by 2 for n is even. For n is odd, mod Cn 1 by n pi, 1 minus cos n pi by 2 for n is odd means 0. Suppose n is equal to 3 substituted here. N is equal to 1. Odd means n is equal to 1. Cos pi by 2. Cos pi by 2 is 0. N is equal to 3. Cos 3 pi by 2 is 0. That is the reason n is equal to odd. Cos n pi by 2 value is 0. N is equal to odd. Find out the quotient here. Even means n is equal to plus or minus 2, plus or minus 4, plus or minus 6. N is equal to odd means plus or minus 1, plus or minus 3, plus or minus 5 and so on. Consider n is equal to even function, even values. N is equal to plus 2. Mod C2 is equal to 1 by 2 pi, 1 minus 1, 2 by 2. 2 by 2 is 1. That is 1 by 2 pi. Minus 1 whole power 1 means that is minus 1 minus into minus plus. That is 2 by 2 pi. That is 1 by pi. N is equal to 2. For n is equal to 2, the value is 1 by pi. For n is equal to -2, c -2, 1 by n is -2 means -2 pi 1 minus -1 whole power and -2 by 2. That is -1. That is 1 by -2 pi. -1 whole power -1 is -1 by -1 whole power 1. Again 1 minus -1. N is equal to 2. N is equal to 4. N is equal to 4. That is C4. 1 by 4 pi 1 minus -1 whole power n by 2, 4 by 2. That is a square. -1 whole square is 1. That is 1 minus 1. That is 0. N is equal to -4. Mod C minus 4 is equal to 1 by -4 pi. Again 1 minus 1 by -1 whole square. -1 by -1 whole square is 1. 1 by 1 is 1. 1 minus 1 is 0. Here also 1 by -1 whole power. That is -1. Minus into minus plus. That is the reason 1 by 1. For even values like that. For odd values, n is equal to 1. C1 mod C1 is equal to 1 by here 1 by n pi 1 by n pi 1 by n pi, that is equal to 1 by pi. N is equal to 3. C3 is equal to 1 by 3 pi. N is equal to -1. C minus 1 is equal to 1 by n is equal to -1 means -pi. N is equal to -3 means mod C minus 3 is equal to 1 by -3. By using these values, plot the magnitude spectrum of that periodic function. This one is n mod Cn. For n is equal to 0, mod Cn is 0. For n is equal to 1. For n is equal to 1 by pi. That is here 1 by pi. N is equal to 2. N is equal to 2. The value is this is also 1 by pi. N is equal to 2. C2 value is 1 by pi. N is equal to 3. For n is equal to 3, that is 1 by 3 pi. N is equal to 4. 0. The value is 0 here, and so on. Here n is equal to -1. N is equal to -1. -1 by pi. minus 1 by pi. N is equal to minus 2. N is equal to minus 2 here, minus 1 by pi. N is equal to minus 3. Minus 3 by 5. N is equal to minus 4, minus 3, that is minus 4, that is 0. This is the spectrum. See the spectrum of that magnitude spectrum of that periodic function. Next, find out. Frequency spectrum and frequency spectrum, not frequency. Find out Fourier series coefficients. Fourier series coefficients are Fourier series coefficients. Coefficients are C naught, not C naught, A naught. Fourier series coefficients are A naught, AN, and B. This is the x of t function. X of t function here. This one is like that. Zero, 1, 2, 3, 3, 4, 4, 5. Minus 1, minus 2, minus 3. Minus 4. This one is x of minus t is minus x of t. Odd function. Odd symmetry. For odd symmetry, A naught is equal to 0. An is also 0. B1, Bn has some value. Now calculate. We know that relation between exponential Fourier complex exponential Fourier series coefficient and these actual Fourier series coefficients is Cn is equal to An minus Jpn by 2. We know that Cn is equal to An plus Jpn by 2. Here 2 Cn An minus Jpn 2 C minus n, not n. C minus n is equal to An plus Jpn. These two are added. 2 C minus n An plus Jpn. Add these functions. 2 into Cn minus C minus n 2An. An is equal to Cn plus C minus. And similarly, 2Cn is equal to An minus Jpn. 2C minus n is equal to An plus Jpn minus subtract 2 into Cn minus C minus n. These two are cancelled. Minus 2z. Therefore, Bn is equal to numerator and denominator is multiplied by j. J into j square minus 1, minus into minus plus. Therefore, Bn is equal to j into Cn minus C minus n. We know that Cn is equal to Cn is equal to 1 by already derived. Cn is equal to 1 by j not magnitude function. Consider Cn 1 by j n pi 1 minus cos n pi by 2. 1 by j n pi 1 minus cos n pi by 2. C minus n is equal to 1 by j minus n pi 1 minus cos minus n pi by 2. That is equal to minus 1 by j n pi 1 minus cos of minus theta is cos theta. That is cos n pi by 2. Therefore, an is equal to, you know that an is equal to Cn plus C minus n. Cn is 1 by j n pi 1 minus cos n pi by 2. C minus n is minus 1 by j n pi 1 minus cos n pi by 2. This one is 1 by j n pi minus 1 by j n pi cos n pi by 2 minus 1 by j n pi minus into minus plus cos n pi by 2 1 by j n pi. These two are cancelled. These two are cancelled. Therefore, an is 0. Already we proved C naught is 0. That is for relation C naught is equal to A naught. That is 0. Now calculate Bn. Bn relation is Cn minus C minus n into j is equal to Bn. Is equal to Bn. Okay. Bn is equal to j into Cn value is 1 by j n pi 1 minus cos n pi by 2 1 by j n pi 1 minus cos n pi by 2 minus into minus plus 1 by j n pi 1 minus cos n pi by 2. That is equal to j 2 times. This one is 2 by j n pi 1 minus cos n pi by 2. J cancel. Therefore, Bn is equal to 2 by n pi 1 minus cos n pi by 2. Therefore, A naught is equal to C naught equal to 0. An is also 0. Bn is equal to 2 by n pi 1 minus cos n pi by 2. Now, here x of t is equal to A naught sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught t. These two are zeros, and finally x of t is equal to sigma n is equal to 1 to infinity bn sin n omega naught t is 2 pi by t naught into t. Here t naught is 4. T naught value is 4. Here T naught is 4. Here Bn is equal to, we know that Bn is equal to 2 by n pi sigma n is equal to 1 to infinity. Bn is 2 by n pi 1 minus cos n pi by 2 into sin n pi by 2 into t. This is the Bn. With this Cn is in this video, Cn is determined. plot the magnitude response, calculate A naught, AN and BN. This is odd function, odd symmetry. For odd symmetry, A naught is 0, AN is 0, BN is present. This is the final Fourier series tension. With this, total analysis is. Thank you. If you like this video, please subscribe the channel for further updates. Thank you.